All right, well, good afternoon. My name is Cameron Nixon, and welcome back to the discussion. Today is Saturday, March 28th, 2020. We got another doozy of a setup on our doorstep with the Storm Prediction Center encircling a little area of western and central Illinois in a level 4 of 5 risk for severe weather. And, before I begin, I just want your word that these discussions are for educational purposes only, and that you are entrusting the hundreds of years of experience between the National Weather Service local offices and the Storm Prediction Center, instead of my 5 as a meteorology student, as your source for decision making. And that you will take this as a fun little adventure into the atmosphere and the dynamics that produce severe storms. So let us begin. We have a strong, broad, mid-level jet stream headed into the Midwestern states, pegging at, I have my readout here, there it is, over 80 knots throughout much of its belt. So pretty fast clip, and if we move to vorticity, again, we're looking for advections in this vorticity across isobars. We're not actually seeing much of that. So given this signal, this trough will likely kind of just lift up north, and if I pull this out a little bit, that's generally what's going to happen. Below that, pull up 850 millibars, we have a very strong warm air advection regime into Missouri and Illinois, up into northern Kansas and southern Iowa. So given this will likely take our current surface pattern, which we're just going to approximate with this wrap. I could pull it out to about what it is right now. And it will take this and likely pull it a little bit farther east, coincident with that warm air advection, and even strengthen it up into Iowa. And if I pull this out again, you can see that is virtually what is going on here. So very rapidly intensifying low-level surface system with that low-level warm air advection, and that will in turn do the whole shebang and through your layers of the atmosphere, again, intensify your mid-levels. This is 700 millibars, and you can see how that system generally intensifies as well over the day, bringing with it a really potent streak of 60s and 70s knots into Missouri, Illinois, and eastern Iowa, even into Indiana over the overnight hours. So this little jet streak is going to be perhaps one of the most important pieces in today's event that really push it over the top in terms of severe weather potential. So what is currently going on? You can see much of the outlook area is actually blanketed in morning convection and leftover cirrus shields from overnight convection. And something that threw a very large wrench in today's forecast was some of said overnight convection. You can see Illinois currently with this thing smack in its middle. And I'm going to explain why that could be a big player. But let me throw this off for a second. And what we're trying, actually, no, I'm going to put that back on because it's a little bit easier to see. We have a vast stretching warm front throughout much of the area, and you can see this with the elevated convection as your warm air conveyor belt rides over that warm front and produces lift and produces all these showers north of that front. So just looking at this map of reflectivity, you could basically see that our warm front is somewhere around here. We also have a Pacific front, quasi-dry line that is currently taking shape right now. It's actually kind of diffuse. You can see some definite convergence in our wind fields as we have mostly southerly, southeasterly flow to the north here, and southwesterly strong surface flow behind that. But again, our dew point gradient is not very impressive. We have upper 50s east of this line, and then lower 40s and the upper 30s behind this line. So this will likely sharpen during the day to some degree with the high dynamics of our system. But this will be a major initiating factor in our storms today. So again, the fun point here is, again, to determine where our storms are going to initiate. Because, as we showed earlier, we have a broad warm sector with strongly sheared flow from those mid-level winds. So again, the expanse of this warm sector could be shown with all these 60s dew points into perhaps a 70 or 2 currently throughout much of this area here, which is all outlined in a Storm Prediction Center risk since you have that shear aloft. So what we do have right now is this nice sliver of clear sky feeding into northern Missouri, into southern Iowa, coincident with some of that dry slot starting to come in from that deep mix layer behind the Pacific front. So what would be some of our initiating points today for severe weather? Well, one, we have this warm front that is very currently moving into southern Iowa and northern Indiana and Ohio. But let's see how that warm front might change throughout the day. If we pull up a 50 temperature, we're looking for a low-level advection that would perhaps scoot that warm front north. And, we're getting a lot of that here. We have our 40 knot, even 50 knot winds at this level, advecting this warmer air into this general region here. So I would not be surprised to see that warm front, which is currently right here in Iowa, to perhaps even move into northern Iowa, into extreme southern Minnesota by the time this day is done. However, what do you see here? But a regime that basically advects air more this way into extreme eastern Ohio and even western Pennsylvania. We don't see that flow wanting to budge this warm front up any further north into Michigan up here. So my guess is that that warm front really will not want to move much farther north than it currently is at the surface here throughout the day. So that is going to be initiating mechanism number 1. Initiating mechanism 2, again, is that Pacific front / dry line that's currently making its way into this area. And we have initiating mechanism number 3 made from early morning and overnight showers here. Have this very expansive, just general, occasionally severe convection along this kind of mid-level cold front, very diffuse again, and just pockets of randomized convection stretching from eastern Texas into northwest Arkansas and Missouri into Illinois. So this cold front is also going to be able to serve as a focus for the occasional severe storm, and we could take a look at how these 3 regimes differ. But before we do that, this cluster I want to talk a little bit more about that did form in kind of around 12Z time frame. This is going to throw a little wrench in things, because see, we had this Pacific front over here, and this was going to provide much of the forcing for today's severe event. However, once you get this here, we could take a look at how our dew points are differing in response to this system. And you can see the general warm sector 65, 67, even 70 south of this, but east of this we actually have some outflowing air, these easterlies. 59 dews, even at 53 it looks like. Yeah, a couple low 50s. This actually might be approaching that warm front. But the system down here is especially problematic as well. Because what do you see north of that? You see 61s, low 60s as well. When you can see that 66 and some other unperturbed dews. I think earlier we were just able to see this a little bit better. Yeah, there's a 68. So a lot of our dew points are being excavated from this convection, because we have all that strong low flow screaming northward. And that's not advecting warm low-level air, warm and moist low-level air anymore. That's advecting rain-cooled air into this area. So this sort of rain shadow might have a very profound effect on how this dry line initiates, especially as it moves closer to here, and even if it does, what low thermal profiles these storms will have available to them. And this storm complex may even serve as a focus for convective initiation too, behind it. But again, the concerns are this cold air currently being generated by the system. So right now we also have a few pockets of warm sector storms, and I guess I'm going to put those in air quotes because we may still have a stable layer below that, so they might not be true surface-based storms, at least for some time. We have this cluster here in southern Indiana, and we have this cluster here being spurred on the south end by this system here. So let's take a look first at the conditions that these cells may be able to utilize. So I step out to about current time frame. Southern Indiana, I'm not extremely worried about this sort of convection. Mainly a weak shear multicellular style hodograph here with generally weak lapse rates. So if this convection just keeps scooting eastward, I'm not really expecting this to be a huge concern other than some occasional hail. However, if you take this convection here, this scattered cellular stuff on the south side of that complex. Currently, we are already recovering in our open warm sector, as we saw with some of our dew points earlier, and we got a pretty nice cape profile. There's nothing here in this profile that really tells me that these cells won't continue to sustain themselves and strengthen. And we have a pretty robust mid-level shear profile here. So these cells, if they are not already, may quickly become supercells. And as you can see, this is some pretty wonky low-level shear profiles. So tornadoes, at least immediately, should definitely not be in the cards. This is actually a shear profile that loves hailstones, as you have some pretty strong low-level flow here, or inflow here, as well as some robust supercell mechanics. So I'm guessing here is that these cells continue to scoot eastward, increasingly gain supercellular characteristics, and produce some occasional hail, perhaps even large hail, as it moves into Indiana, perhaps north of Indianapolis, and continues further. Again, I'm not sure how long this thing can last. There's really nothing that is stopping it at this point, especially as we continue to boost our cape throughout this general area where it's going to travel. So with that in mind, are we going to see a further development along the warm front later this afternoon? If this comes cruising across here and excavates the instability from north of there, my answer is going to be no. But could it, if this thing scoots east fast enough, could there be some redevelopment behind it? That's a definite possibility. And could it also spur some cells ahead of it, like what's currently happening right now? That is also a possibility. So if we take this out a few hours, let's go to 22Z just for an idea, and take a look at some of the air that has replenished itself behind these cells. We should first take a look at what our shear might be doing. By about that time in mid-afternoon, this jet has moved into the area. So our shear profiles are probably going to be a little bit better for supercell dynamics than they currently are. And our warm air will have likely overspread this area as well because of that strong deepening system. So we could pull a sounding somewhere around here, a little bit near the Champaign area. Lots of traffic today. And you can see again this cape profile is very similar to what we saw earlier, uncapped with decent level cape and a pretty manageable cape profile throughout the deep layer. And as that jet stream came in, we have some very strong 3-kilometer flow leading to some pretty powerful 0 to 3 kilometer shear. And I guess I want to reiterate, this is very strong 0 to 3 kilometer shear for many events. And this is I like to call this is like the classic Illinois warm front profile, because you do have weak, slightly backed surface winds, and then you have a strong mid-level vortex or something causing these winds to be very fast in the 3-kilometer layer. And these have led to a multitude of sometimes quasi-mini supercells capable of slightly longer track tornadoes than expected. So this is definitely a sort of strong tornado sounding, perhaps a longer-lived tornadic sounding. So this is definitely a possibility. Once this clears out, again, that is not a fact. That is not guaranteed. But if that does occur, that is what our atmosphere will likely recover to. However, if this does spur some cells along its southern end that continue to develop perhaps into eastern Indiana, into northwest Ohio, we could also take a look at that parameter space, maybe kick it out another hour, and we could go somewhere around here. Lots of waiting today. And we have a little bit of a weakness in our shear profile, kind of like we did earlier. So I'm not exactly sure the extent of what is really going to happen with this cluster currently going on right now. It is likely, I guess in my opinion, to maintain kind of the steady state hailing complex as it moves here, and I guess most of our severe weather could be confined to this area and not really much higher above it if it were to kind of suppress that warm front. So I guess we are done with the warm front target. So now we shall move to the dry line Pacific front target. So as we said earlier, this warm front over here on this end is likely to lift further north throughout the day due to that strong low-level advection regime. And let's, what should we look at? Let's look at our mid-level winds. Again, this streak is forecast to move and lift with our upper level system north into northern Missouri and eastern Iowa and western Illinois. And you can see that as I draw this out throughout the day. So this is going to especially make for some of the most extreme shear profiles, especially since you have the backing of that upper level jet as well, which will strengthen your deep layer shear beyond 3 kilometers, which we saw earlier that this target really didn't have much of. And also make our storm motions exceedingly fast. So I could step this out as well. We can actually pick a little bit across this dry line to get a taste of when storms could initiate too. So if we went around 16Z, we still have a little bit of capping residual, especially from that morning convection that may suppress initiation along that dry line. But as we move a few hours further to around 18Z, you can see that it is generally, this cap is generally being overcome by our cooling mid-level flow above that and our warming surface temperatures. So I'm guessing somewhere between 18Z and 19Z is when we do start getting hints of CI along this Pacific front. That will start moving into this warm sector. Now, this will definitely depend on how, the amount of miles that they cover basically will depend on how northward that warm front gets. Again, I do believe it could make its way all the way toward northern Iowa And the warm sector is moving at a very fast pace too, so I don't really expect these storms to outpace this front either. So let's plot a sounding at around a couple hours after initiation here in eastern Iowa. Let's see what we got going for it. So some very, I like, in terms of supercell dynamics, this is a very supportive sounding. It has it has strong shear dispersed through a very deep layer. And that's arguably most important in terms of strong supercell dynamics. And especially with our semi-straight shape, large hail is definitely a threat for any supercells that do form along that front. So our instability profile is also rocking too, because we do have our coldest mid-level temperatures are over that area. It's almost like a quasi cold core region too. So a lot of our colder mid-level temperatures are up here, and combined with that rapid introduction of low-level moisture, that is going to create our steepest lapse rates in the low levels by far. So this sounding here, clearly a hail sounding, also clearly a tornadic sounding, potentially significant. The only thing that keeps me from going stronger on tornadoes is the fact that this moist sector might be fairly skinny and might not give storms ample time enough to mature and produce longer-lived tornadoes. And then B, that these are extremely favorable hail profiles with this very thick cape here, and our long and straight photographs. As well as that long straightness in the mid-levels enhances the production of left splits as well. Even if we are curved in the lowest levels, there are going to be left splits today. That is going to make for a pretty messy storm mode, especially as you get closer to areas where the shear vector is 90 degrees to your Pacific front. So I'm especially looking at the eastern Iowa and western Illinois areas as places where storms might really succumb to a lot of splitting and merging and bashing and thrashing. This is a really uncertain area, in my opinion, to get a supercell that's long-lived enough to produce a tornado that lives up to its true potential. So if I scoot this out a couple more hours and look at the general northern Iowa area, see if that's changed at all. And again, incredibly supportive photograph for robust supercells, capable of very large hail and definitely a strong tornado threat as well. So really, I'm really set on some activity up here because again, you have that you have forcing for discrete with that shear vector largely perpendicular to this boundary. Even if you have a lot of splits, there's going to eventually be a southern cell or two out of each cluster that does survive as a right mover to take on these right mover qualities. And we can continue going down this line. Look at the western Illinois target. I doubt there's going to be very much difference in the profiles as well. Yeah, so virtually the same thing. You have very strong low-level cape, mid-level cape as well with these steep mid-level lapse rates, and photographs wildly supportive of robust supercells, especially splitting supercells. It almost looks like our hump is a little bit weaker on this one, which, look at that anticyclonic curvature for these left movers as well. Very strong supercell dynamics here. And these may persist. Whatever supercells do initiate off this line will actually likely perish in northern Iowa by 0Z, but the ones that form further down this line could keep living into north central Illinois, and I could scoot this out by maybe 1Z, just in case a cell was able to last long enough in that warm sector before becoming eaten by stratiform rain around it or other cell collisions. And this is when you really start getting photographs that are favorable for significant tornadoes and especially longer-lived tornadoes. So this definitely hits a little bit more analogs. You have strong, straighter 0 to 1 kilometer shear, a little bit weaker mid-level shear, so a little bit less favorable for hail production, and still very strong low-level cape even after dark. So these definitely get tornadic in a hurry, especially once you get around sunset. But again, the issue is, are there going to be storms that last until that time? So our third mechanism, again, is this cold front stretching from southern Illinois down into even the Gulf of Mexico. And again, the regime for that none of these are perfectly suited for what I want. Come on, there we go. Again, the regime for that was basically these randomized clusters of storms. You can see one here already taking shape. If our moist sector were to get up to it in time, this may provoke a slight threat for tornadoes, given that the photographs are good, so we'll look at that. And then any clusters down here will eventually make their way up here. So this will be a very sporadic, probably all day threat into the evening hours, early evening possibly, or late evening, possibly even into the early morning, as this shifts eastward into eastern Arkansas and perhaps extreme northern Alabama, into western Tennessee, into Kentucky. So again, a very sparse though threat, and it will mainly be damaging winds with this kind of quasi cellular linear mode, and we could pull up a photograph to assess what our supercells would be like. Start about right now with this couple cells in northeastern Arkansas. So these cells down here are a little bit away from that mid-level jet streak that we were talking about earlier. So our low levels are definitely pretty wonky. So this is again perhaps a hail only, if anything, photograph. We do have some pretty strong shear from 0 to 6 kilometers. So this could definitely support some persistent supercells earlier on. And again, we have strong 3 cape, indicative of a very moist sector here, but this will generally only be leading to robust updrafts that could produce large hail. And if we step this out even further, we can go into this general region. And we see our photographs are curving slightly more than they were, but we still have that weird lack of that mid-level forcing to give us those really favorable photographs for anything but supercells capable of hail. It is the early evening hours that I'm a little bit more concerned about, as far as I remember, for this cold front target, especially as we move north, and these photographs become a little bit more favorable for tornadoes. So we could get a sporadic tornado or two with these isolated clusters if a couple cells were to remain active, and we can continue to step that out. That worm sector continues moving into even southern Indiana by near midnight, and I can pluck another sounding for that. You'll likely see that our photographs become even more favorable for tornadoes. This is a significant tornado sounding for sure. Perhaps if we do have a cell that is allowed to live long enough, and especially provided a surface vorticity source by a QLCS or other linear segment, this could produce a relatively longer lived tornado as well. So again, our probability of that is very low and very sparse, but again, the environment does exist here. So wow, that was, I'm almost out of breath right now. That was quite a in-depth discussion, and I am not afraid to go all out on this one because it is very fun for me to learn and take all these little pieces and all these different target areas and try to assess what's going to happen with each of them. And again, I'm not your official source. The Storm Prediction Center and National Weather Service are indeed your official source, and I'm interested to find out what is going to happen today. So have a great day, everyone. Stay safe.